Today we're going to do adding and subtracting radical expressions and multiplying radical expressions. So we're actually going to cover lessons 7 and 8 today. So when you're adding and subtracting radical expressions, you must have like radicals. Right? So just like in the warm-up, to be able to combine any of those, right? So to be able to combine here in 1, 2, and 3, we had to have like terms, right? We always say, all right, so to add with variables, you have to have like terms. Well, with radicals, we have to have a like radical to do it. So here is an example of some with like radicals, which means that what's underneath the radical sign, they have to be the same to be able to add them. All right? So like here, they both have square root of 5. These are square root of x. These are the square root of 4t. So I could combine them by adding or subtracting because they have like radicals. Where these other ones here with the square root of 15 or 6 square roots of x and square root of 6x, okay, those are different. 3 square roots of 2, 2 square roots of 3. So what's underneath the radical must be the same for you to be able to put them together by adding or subtracting. And then just like when you're adding like terms, we keep the like term the same, and then we add the coefficients. The same thing happens with radicals. So like here, 2 square roots of 5 plus 4 square roots of 5, 6 square roots of 5. Okay. 6 square roots of x minus 2 square roots of x, 4 square roots of x. So we take the coefficients and either add them or subtract them depending on which one they're asking us to do, as long as the radicals are the same. So, for example, A here, 9 square roots of 3 minus 4 square roots of 3. That's just 9 minus 4 is 5 and square root of 3. All right, so if I have the like radicals, I could just add the coefficients together. All right, so do B and C. So that's the basics for adding and subtracting them. This, if you have like radicals, then we can put them together by combining the coefficients. If the radicals are not the same, then you can't do anything with them. All right? Sometimes radicals do not appear to be alike, so you actually have to simplify before you can try to put them together. Right? So if we look at this example here, square root of 45 minus the square root of 20. Right? So those two right now are not like radicals, but they can be simplified. So the first thing I have to do is I have to simplify them. Then I can see if the radicals are, if I have like radicals or not. So the square root of 45, what's the largest square that goes in the 45? Okay. 9 does. So we'll rewrite the square root of 45 as the square root of 9 times the square root of 5. And the largest square that goes into 20 is 4. So this would be the square root of 4 and the square root of 5. So I kind of skipped a step here. I'm okay with that if you do that, okay? If you go right to this step here, right? So we get 3 square roots of 5 minus 2 square roots of 5. Oh, now I do have like radicals. So 3 minus 2 is 1. So this is just the square root of 5. So sometimes you have to simplify it first. Then, if you have like radicals, you can put them together. 9 square roots of 75 plus 2 square roots of 50. So first of all, we need to simplify these radicals. So we have 9 square roots of 75. 25 is the largest square that goes into 75, so this is 9 times the square root of 25 times the square root of 3. Plus, the largest square that goes into 50 is also 25. So 2 times the square root of 25 times the square root of 2. Now, mistakes that are made quite often are made here when we put the 9 and the square root of 25 together, because lots of times students will add those when, remember, if there's no sign between, it means multiplication. So we have 9 times 5 times the square root of 3 plus 2 times 5 times the square root of 2. So make sure you multiply these together. You don't add them together, and that's a common mistake. So we have 45 square roots of 3 plus 10 square roots of 2. And since those are not like radicals, that's my answer. So basically all I did then is just simplify them. So we simplify the radicals, simplify the expressions, and then if we have like radicals, we'll add in or subtract them. All right, one more. All right, why don't you go ahead and work on this one. The y really in this case doesn't make a whole lot of difference to it. All right, we're still going to do everything the same. Square root of 25, and then it's just the y is going to stay with that other number. Okay, minus 2 times square root of 9, square root of 3y, plus square root of 16, square root of 3y. So I can see I have the like radicals. All right, here we have 5 minus, and the square root of 9 is 3, so 2 times 3 is 6, and square root of 16 is 4. All right, so we have 5 minus 6 plus 4 is 3 square roots of 3y. So when we're adding and subtracting radicals, you just have to make sure you have like radicals. If they're not the same, you can't put them together, but if they can be simplified first, then you need to simplify them and then see if you can combine them together. All right, so there's the adding and subtracting. All right, multiplying radicals, we're just going to be multiplying today. We're not going to do the multiplication and the division. All right. So just like with adding radicals, if we have like radicals, we can put them together. But when we're multiplying radicals or multiplying square roots, we're just going to multiply the numbers that are underneath the square root sign. Right? So if you have numbers underneath the square root sign, they can be multiplied together. Right? So here, the square root of 8 times the square root of 6. Right? Because both the 8 and the 6 are under the radical, and we're multiplying them together, we can multiply the 8 and the 6. So this just becomes the square root of 48. And then if you can simplify the square root of 48, then we need to simplify the square root of 48. Okay, so this is square root of 16, square root of 3, so 4 square root of 3. All right, so when we're multiplying radicals, all right, any number that's under the radical sign, we are going to multiply together. All right, letter B. All right, I'm going to look at letter B two different ways. All right. One is that when you square this, reminder that that means it's multiplied by itself. So what I'm going to do is I'm actually going to rewrite this and put the numbers that are outside the radicals next to each other and the numbers that are under the radicals next to each other. All right? So, because sometimes we tend to do FOILing here when that's not really the right method to do it. So here I got 2 times 2 is 4. And what's the square root of 5 times the square root of 5? Okay, it's the square root of 25. All right, so this just becomes 4 times 5, which is 20. All right, that's one way to do that one. All right, okay, you remember that if it's squared, it's times itself. But by rewriting it so that I have the numbers that are outside the radicals together, numbers on the inside together, usually will work pretty good for you. The other way to think of this is this way. All right. This is 2 squared times the square root of 5 squared. Okay. Well, what's 2 squared? 4, right? Okay. And if I square a square root, those undo each other. And so the square root of 5 squared would just then be our 5. And we'd get 4 times 5 is 20. Right? So you can do this either way. All right? So whichever way you're most comfortable with is the way I would approach it. All right? But the big thing to remember is it means it's times itself. Okay? All right, so you do letter C here. So if there's anything that's under the radical in that multiplication, I can multiply them together. All right, so we multiply these two together. We get the square root of 36, 3 times 12. Y times y is y squared. So if you need to, you could pull that apart. Square root of 36, square root of y squared. So we get 6y. All right. So you should be able to go from 36y squared to this also. If you need the extra step, then take it. That's fine. So when we're multiplying, we can multiply. If we're multiplying 2 radicals together, I can multiply the numbers underneath the radicals also. All right? So let's look at the distributive property. Now the thing is, we can only multiply things together that are either outside of the radical or inside the radical. So with this first one, the square root of 3 times 7 minus the square root of 8. Right? When I multiply the square root of 3 times 7, now the 7 is not under the radical, so that's got to be outside of it, so that's going to be in the front. So it's going to be 7 times the square root of 3. All right? We can't do anything except for write them next to each other. All right? Because this is the constant and the radical. Right? But when we multiply these two together, we're getting minus the square root of 24. And as you're going through these, you should, some of these you should just, oh yeah, I know exactly what that one is, right? All right? If you do enough of them, you should know what they are. You know, a few of them that we use a lot would be like the square root of 8. Okay, you should get that that's 2 square roots of 2 eventually. Square root of 12 is a pretty popular one too, so that's 2 square roots of 3. And square root of 24, you're probably going to see that a few times. Right? So we have 7 square roots of 3 minus, and so 24 is 4 times 6, right? Okay. The biggest square that goes into 24 is 4. So this is 2 square roots of 6. So there's my multiplying those together using the distributive property. Right? But if it's outside of the radical and you're multiplying it by something that's a radical, it's got to stay on the outside. Right? So you do letter B here. Right, good. Okay, so we multiply these together, we get the square root of 16. Multiply these two together, we get the square root of 36. So 4 plus 6 equals 10. Okay. Good. All right. Okay, so there's the distributive property. Foiling, all right, or using the distributive property twice. Chapter 7, we learned to multiply binomials together. So we're going to do that with radicals. So multiplying sums and differences of radicals. All right, so we do it just like we did it if it said x plus 3 times x minus 5. Have the same procedures. Okay. So here we've got 3 minus the square root of 8 and 2 plus the square root of 8. So that means we have to multiply the 3 by both in the other parenthesis, and we have to multiply the square root of 8 by both in the other parenthesis. All right, so we're going to do the distributive property twice. So we'll multiply 3 times 2, we get 6. 3 times the square root of 8, so we get 3 square roots of 8. Remember, the 3 is not under a radical, the 8 is, I can't put them together. Multiply these two together, we get negative 2 square roots of 8. And square root of 8 times the square root of 8 minus the square root of 64. Now, when you multiply them together, all right, anytime we do square root of something times itself, all right, this is just 8. All right, so you don't necessarily have to write the square root of 64, and or the square root of 5 times the square root of 5. That's just 5. Okay, whenever you multiply square root times itself, it's just that number, whatever's underneath it. All right, so here we get 6 minus 8, and we have 3 square roots of 8 minus 2 square roots of 8. Now I'm writing it out this way, you don't have to, but I'm just adding that step just so we can see it. Okay. So 6 minus 8 is negative 2. 3 minus 2 is 1, so we get the square root of 8 there. Right. But is that the final answer? Okay, it's not, because we can still simplify this square root of 8. Right? And like I said, this is one that you're going to see a lot probably, and so you can memorize it. Okay, this is 2 square roots of 2. So my answer here is negative 2 plus 2 square roots of 2. Right. Those situations, if you've got it memorized, the simple ones, you don't need to show me any work for those. Okay, square root of 4, square root of 8, square root of 12, square root of 24. Those are all that we see a lot. And so if you know it in your head, write it down. Okay. All right, so we FOIL. Multiply the first term times both of them in the second expression, second term by both in the second expression. Letter B, 4 plus the square root of 3. So once again, when things are squared, what does that mean? It means we multiply it by itself. So this is 4 plus the square root of 3 times 4 plus the square root of 3. So I can't, I said over here that we can use this little trick here, all right, when it was squared, but that's because there was no plus sign between them or minus sign between them. So it's different if we have a sum or a difference. You actually have to multiply them out. So 4 times 4 is 16. 4 times square root of 3 is 4 square roots of 3. Square root of 3 times 4, 4 square roots of 3. The nice thing about when they're squared, when it's a square, is you get the same term twice in the middle. Okay? And square root of 3 times square root of 3, like I said, that's just 3. If I multiply a radical by itself, I get what's under the radical. All right? So this is 19 plus 8 square roots of 3. Okay. So adding and subtracting, you have to have like radicals to be able to put them together. When you're multiplying, I can multiply things that are underneath the radical, I can multiply them together. If something's on the outside, something's on the inside, then we have to keep them that way. All right. Okay. Any questions?